In this video, I will be going through the first 15, 1 through 15 for us, and then we'll post other videos for the other problems. Okay, with problem 1, we're asked to find the area of the region enclosed by the graphs of y equals x squared and y equals x. So let's see what it's asking for. We have our parabola, y equals x squared, and then we would have our line y equals x. So imagine this was better drawn, so you're looking at that bounded region there. Number 1, I've gone ahead and drawn a quick little sketch. You're finding the area of this bounded region, and remember you do integrate. So our area, and we're going to integrate, and we need to do from endpoint to endpoint, and so move on to number 1, and with number 1, okay, for the very first one, we are trying to find the area of the bounded region, and we have two functions, y equals x squared and y equals x, and so we can do a quick sketch of these and see, well, what's going on with them, because we would have to integrate these, and we really need to see, well, which function's on top. And notice it is the y equals x function on top, and then y equals x squared on bottom. So I know when I integrate, I'm going to have the integral of x minus x squared dx, but then I've got to figure out from what to what. I need to find my endpoints. And so for the first endpoint, we see very quickly 0, 0. And again, for this one, if you don't see it right off, remember those endpoints are found by setting our two functions equal to each other. So we see, yeah, 0, 0 makes sense. But then the other point here, I would think it would be 1, 1. And you could, if you're not sure, if you don't see those right off, of course, you can subtract x over and then factor. And notice you do get endpoints for 1 and 0 there. Okay, now as continuing on through our integration process, we will have, let's see, 1/2 x squared minus, and let's see, that's going to be 1/3 x cubed. And I need to evaluate all of this from 0 to 1, which is nice because the 0 will cancel everything. So if I substitute in 1, I have 1/2 times 1 squared minus 1/3 times 1 cubed, and then of course all of that minus, and then the bottom endpoint is going to generate 0. And so finishing out this problem, we see we really end up with 1/2 minus 1/3, so that's going to be 1/6, and that should be answer choice A. Okay, moving on to this problem, it's very tempting to think that this problem is the definition of a derivative, and it's almost like they're trying to make you think that, but look at this denominator. You have x squared here. So remember that limit definition there, you would not have that h squared there. Most of the time you're going to have an h. So let's look at what would we get if we actually plugged in our function, because my f of x is here, and then f at 0 is going to be 1. So let's see what our limit will become. We have the limit as x approaches 0, and we're going to have 2x squared plus 1 minus 1 all over x squared. And so we see we have the limit as x approaches 0, and we're going to have 2x squared in the numerator over the denominator of x squared, so we get our limit value to be 2. So I have answer choice C. Okay, now this problem is more of a thinking problem. We have a polynomial, and that polynomial is of degree n. So that's the highest power I see is degree n. And it wants to know, well, what's the degree of q if we integrate p to get q? So really this problem, it seems like it would be much more difficult But think about the process of integration. So integration, if x was n, wouldn't you add 1 to that n? And of course, that's what it tells you to divide by. But if your highest degree, or the degree of p, is n, then the highest degree, or the degree of q, would be n plus 1. So that's going to be answer choice E. Okay, number 4. So for this problem, we have a particle motion problem, and we want to know the value of dx dt. So we're looking for dx dt, and we're told that xy equals 10, and we know the value of x is 2, so we can conclude that y is 5, of course. And we know that dy dt is 3. So we're going to have to go through and do some implicit here. So, and the product rule. So we have first times the derivative of the second, dt, I almost wrote x, plus second times the derivative of the first, so dx dt. And that is going to be equal to 0. And I would go ahead and just fill in all the information that I know. We know x is 2, we know dy dt is 3, plus y is 5, and dx dt is what we're trying to find, and equals 0. So from this, we can quickly see that our answer should be negative 6/5. So that's answer choice B. Okay, number 5, which of the following represents the polar curve r equals to secant theta? And notice every part of the graph is in terms of x and y. So we need to change from our polar form to our rectangular form. Oh, I forgot my 2 here. All right, so we need to remember that secant is 1 over cosine. And then our polar to rectangular conversions, remember that x is equal to r cosine theta, and that looks like that's what we'll be using here. We'll multiply cosine over, so I have r cosine theta equals 2, and from there we see that x is 2, so we need to find the graph of x equals 2, and that's going to be answer choice D. Okay, number 6, we are finding the second derivative, but we have to be careful here with our second derivative. In this case, since we are in parametric form, we have to remember that there's a little formula. Of course, we do take the derivative of our dy dx, but then we also have to come back and divide by our dx. So let's go ahead and see what we get when we start finding our derivatives. So dx dt is going to be 2 times t, and dy dt is going to be 3t squared. And to get dy dx, we will divide. So we see that dy over dt over dx dt, that simplifies just to be dy over dx. And so we're going to take our 3t squared and divide it by 2 times t, and then that's going to give us 3 over 2 times t. But now remember, we need our second derivative, so let's come back up and look. So I need to find the derivative of 3/2 t. Well, the derivative of 3/2 t, that's just going to be 3/2, but then that has to come back and be divided by our dx dt, which was, and I guess I didn't write that dt there, dx dt, which is 2 times t, and then that's going to simplify to be 3 over 4t. So that's going to be answer choice A. Hey, this problem looks complicated, but it's really just a straightforward u substitution problem. If you let u be x to the fourth, then you see that du is 4x cubed. And so that's going to work out to be quite nice because now you're integrating e to the u du. You have your 1/4, and that's just going to turn into 1/4 e to the u, but then remember u was x to the fourth, and then we have to evaluate this from 0 to 1. And so when we plug in our endpoints, we should have 1/4 e to the first minus 1/4 e to the 0 power, and a lot of times people try to make that e to the 0 power 0, but it's not. It is all going to go to a 1, so that's minus 1/4, and we can factor out a 1/4, and that's going to give me e minus 1, which is going to be answer choice A. And number 8, if f of x equals the natural log of e to the 2x, now we do need to remember that if we take the natural log of e to the x, we can move that exponent down to the front, and that's e or x times natural log of e, which natural log of e is 1, which just gives us x, which was our exponent. So we can reduce this before we do the derivative to just 2x, and then that means that f prime at x is 2. So you should have answer choice B. Okay, for this problem, we are asked about which of the following is not true about f of x. And I'm seeing some second derivative. We're seeing things about f increasing. So I would go ahead and take the derivative. And that way we can see, well, a little bit more about increasing and decreasing and such. So we're going to have 2/3 x to the negative 1/3, which is really just going to be 2 over 3x to the 1/3. And then looking at all of our answer choices here, very quickly glance, look at answer choice D. F prime at x exists for all x. Well, that's not true. We see that x here cannot be 0. So very quickly we found the one that was not true. Okay, for the next one, which of the following functions are continuous at x equals 1? Well, let's just see. If we are continuous at x equals 1, well, let's think about the graph of natural log of x. Well, the graph of natural log of x does something like this, and that point there is 1, 0. So, yeah, that would be true. So then that's going to get rid of B. And let's see, what else can it get rid of? It's going to get rid of D. Okay, and let's see, E is all 3. So we're going to have to continue on. All right, so for the next one, now e to the x, if we look at the graph of it, e to the x is the inverse, of course, the natural log of x. And it does something like this. So, yeah, you would be continuous at 2 for sure. Now, let's look at number 3. So, with number 3, natural log of e to the x minus 1. The graph of natural log of e to the x minus 1 is very similar to the natural log graph. It's a little more bent, and so when we graph that one and look at it, then it is a little bit closer. We don't cross quite at 1, but it's a little bit closer, and it kind of flattens out here. So that one is also continuous. So that's going to give us answer choice E. Okay, so for this problem, whenever you have an endpoint that is approaching infinity, we have to do some different things with this one, and we'll do very similar to a u substitution, but we're going to make that endpoint B, and because this is approaching infinity here, that top endpoint shooting off to infinity, we can think about it as a limit and let that endpoint b approach infinity, and then do the integral from 4 to b, and then we can go ahead and finish looking at this problem. So we have negative 2x over the cube root of 9 minus x squared. And it looks like we'll also need to do some sort of u substitution with this. So as we continue on, I would let u be 9 minus x squared here. And so du is negative 2x dx. And so I have a negative here that I'm going to throw out. So I'm going to have here a negative, and then we have the limit as b approaches infinity, the integral from 4 to b, and it looks like we ended up with just 1 over u to the 1/3, or u to the negative 1/3 du. And so again, bringing all this down, limit as b approaches infinity. And if we integrate here, we're going to get u to the 2/3, and so 3/2 at the front, evaluated from 4 to b. And I'm going to throw that 3/2 back out to the front, so I have negative 3/2, and then the limit. And we do need to go back and replace what my u value was. B is approaching infinity of, and let's see, u was originally 9 minus x squared, so I have 9 minus x squared, and that's going to be evaluated from 4 to b. So again, negative 3/2, and here the limit, again as b approaches infinity, of, and we're going to have 9 minus b squared, 9 minus b squared, minus, and then we're going to have 9 minus 16, so 9 minus 16, yeah. Okay, so looking at this, notice b is increasing without bound, and then we're going to square it, so it doesn't look like we're going to get a limit value there, so it looks like my answer should be E. All right, number 12, a good particle motion problem, and it looks like we're given position, and we want to know when time t equals pi, the acceleration of the particle is. So we need the second derivative here. So let's see, what would be the velocity function? If we did our derivative here, we would have 2 cosine, I don't know why I wrote a negative, excuse me. That's just going to be 2 cosine 2t plus 3 sine 3t. And now we need to find our acceleration function. So again, we need that next derivative, which is going to be negative 4 sine 2t, and then plus 9 cosine 3t. And I want to know, well, what is the acceleration when time equals pi? So if I plug in pi here, that's going to be negative 4 times sine of 2 pi, which is 0, plus 9 times cosine of 3 pi is going to be negative 1. And so it looks like I'm going to get an answer of negative 9, which is answer choice E. Okay, with this problem, it's really saying that we've taken the derivative of something and we got this for an answer. So what was the original? So here I would do some separation of variables and then do an integration. So if I integrate both of those, I'm going to have the natural log absolute value of y. It's going to be 1/3 x cubed plus c. And again, remember ln log base e. So y is going to be equal to e raised to the 1/3 x cubed plus c. And here the way we need to deal with c's, remember whenever c plus c is in the exponent, you were really multiplying with like bases, and you can break this apart to be e to the 1/3 x cubed times e to the c power but e to the c power is still some constant c times e to the 1/3 x cubed. So it looks like answer choice C would be the best option here. Okay, for this problem, we're given the derivative of f, and we want to know how many relative maximums does f have. So f would have relative maximums when f prime changes from a positive to a negative value. And since they've already given us in factored form the derivative, we need to go do a number line analysis, and we need to check our signs at the zeros. So that's going to generate -3, and then we're going to have a 0, and we're going to have a +2. Now, something for us to pay attention to here. Notice the exponent on x itself sitting outside is to the 4th power. So that tells me that we're not going to have a sign change here. There's not going to be a sign change at all around 0. So just to double check though, let's do some real quick points, and we will plug back in here and see what we end up with. So the first test point I would try would be -4. And if I plug in -4, I'm going to have, let's see, a positive value from x to the 4th. And then for the next one, I'm plugging in -4 minus 2 is negative. -4 plus 3 is a negative. So that's going to tell me those values are positive. Now for my next test point, I would choose something a little bit easier. Let's choose -1 and substitute into that factored form. And again, we're going to have a positive. -1 minus 2 is negative. -1 plus 3, that's a positive. So here we're going to have a negative value. Now we should have a negative value on the other side of 0 as well, because we are not going to have a sign change because of that x to the 4th. If we plug in +1, notice we have a positive times a positive times a positive. So here, notice that, oh, not a positive, my gracious. 1 minus 2 most days would be a -1. I do apologize. So that is going to be a negative, and that supports our theory of no sign change. On the other side of 2, everything would be positive once we plugged in. So again, we're looking for that relative maximum, and that's going to occur when I change from positive to a negative value. And around what number does that occur? Here at -3. Notice here at 0, we don't have a sign change. And then at 2, that's going to be a relative min, because it's really the opposite. We changed from a negative to a positive. So here, this is my relative max. So it looks like I have one relative max. Okay, so for this problem, we need to find the derivative. And just a quick reminder, if you do the derivative of e to the stuff, use a nice word, stuff, you will get the derivative of stuff times e to the stuff. And again, use nice words for stuff. And so if we want to do the derivative of e to the tangent squared x, oh my, well, let's see, we have to think about this as really e to the tangent x all squared. That way we make sure we address this derivative correctly, which is going to be chain rule. So when we do our stuff prime, we're going to have 2 tangent x all to the first times the derivative of the inside, which the derivative of tangent x is secant squared x, and then just times e to our stuff. So then times e to the tangent squared x. So that looks like we're going to get answer choice D.